All right, I thought we had made it farther than this slide. All right, these are terms we need to understand. I think I've mentioned them already. Broadly speaking, there are three classes of errors. Have I mentioned those? Not sure whether the book mentions them specifically as 2 or 3. I'm just going to launch idle and type the notes in directly in there. All right, so file new. Always do a file new. Save as. You don't have to type the notes in as I type them unless you just like to, right? Totally okay if you want to. So I believe we're on lecture E. Not sure how we did that if we missed a day last week. Is that true? Oh, that's because I'm looking at the wrong page. All right. So we have to be on lecture D now. All righty. All right. 3 types of errors. Syntax errors. And then the book refers to something called logical errors. They're leaving out, or they are combining in this category 2 separate kinds. So I'm going to throw a third in, which are runtime errors. Runtime errors are not really a failure of logic. They're okay. Syntax errors, I think we understand what we mean, right? We missed a colon. We indented in a place we shouldn't have. We missed a quote. We misspelled a variable name. We put an uppercase letter where there should have been a lowercase. Those are all, errors in the grammar of the language, in the syntax of the language. Then there are logical errors. The program runs, but not successfully. Whatever task it was trying to achieve, right? There's no syntax errors in it. But whenever you try to convert Celsius to Fahrenheit, it always says it's 100 degrees, right? No matter what. Or it's supposed to turn a thermostat on, and instead it turns the cooler on. Or you step on the brakes, and instead it applies the accelerator, right? Bad stuff like that. So those are all logical errors. They can also be... And then there's the third category, in my opinion, and I think the textbook is categorizing them as logical errors. Runtime errors. That's when the program gets into a state from which it cannot recover. It was writing to a disk, but somebody unplugged the drive, right? Or the disk ran out of space, or the file name had an illegal character in it, or we lost our connection to the internet, right? Things that the program was expecting to work, but no longer can because of the state it got to. Now, you could argue that your program should be able to handle that state, and so it's in the long term a logical error. But I kind of want to break them apart, right? A logical error is when you've written the logic wrong. A runtime error is when you wrote the logic right, but maybe it wasn't complete enough to handle a situation like dividing by 0 or bad file name or running out of disk space, stuff like that. That's why I like to categorize these as separate things. 1, 2, and for me, this is a third category. Maybe they would just call it, 2.A or something like that. So the program reaches an error state and stops. And we've seen those too, I think. Right. The program runs, it's not a syntax error, but then after a while, right, it gets an error in a line of red text. Could be that we got string input and the user entered bad input, and so we couldn't convert it to a float. Or we forgot to convert it to a float. It's not a syntax error. The syntax is perfect, but it was, that was a runtime error. And in those cases, or specifically in the case of us forgetting to do something, that's more of a logical error. In the case of the user typing it in lousy, that's a runtime error. which could be corrected through logic. Hope that makes sense. If if you're taking a quiz on the exam, excuse me, on MindTap, and it asks you, you're going to crank out those two answers. Just remember that I want you to think about that one as well. So a logical error is we have a correct statement, but the wrong one for the current context. That's a weird one. That's a weird way of saying it. I mean, I guess it makes sense, but like if your if statement is supposed to be if x is less than 18, so that you can check to see if they're supposed to be able to vote, but you wrote if x is greater than 18, I guess that's the wrong one for the current context, but it's a logic error. So testing. Testing is to see if your program works, or if you can make it to fail. Whenever a programmer writes a program, they test it to see if it works, right? I'm going to add two numbers together. Well, I'm going to type in two numbers. Woohoo! It added two numbers together. My program works. But you need to find out if you can make it fail too. As much as you can, with the knowledge that you have, you want your programs to work under all circumstances. You don't want it to fail, to be able to fail. For example, if you ask a yes/no question and they type in y in uppercase rather than lowercase, we'd like for those to be treated the same way, right? We don't want the program to stop running just because they used uppercase y rather than lowercase y. It's kind of a logic error, but the program did not succeed when we expected it to succeed. We were able to make it fail by varying our input. One of the things you do is you test your boundary conditions, meaning that if the break-off for voting is 18 years old, you test 17, 18, and 19, right? 18 is the edge. You want to make sure that it works for all three of those cases. And like I said, the programmer always just tests it to make sure it works right. You don't try to break your code. But that's part of the skill of becoming a programmer as well, is trying to break your code. And in a large company, you will have an entire separate testing department, right? You can be sure that the people, at the large video game companies, that they have a room full of people trying to break the program, right? And they're trying to, walk their character off the edge of the screen, or, and they're trying to find glitches and errors in it, because if you don't find it, then the end users are going to find it, and they're going to be annoyed, right? So testing it. Testing it with sample data to see whether the results are logically correct. Not only that, you're testing it as much as you can to make sure it doesn't fail for the cases that you can predict, right? You might not be able to predict them all. You might not expect the user to type in uppercase rather than lowercase, but after a while, you get a feel for what you should test for. Testing is separate than debugging, but they go in the same, hand in hand. If there's an error, right, like I typed in I'm 4 years old and it granted me a voting card, then I have to debug. I have to figure out what's wrong. I may have to test it a couple times in order to figure out what's wrong, right? I go and look at the logic, I enter some different data, I make a change to the logic, I enter some data, right? It's kind of a cyclic thing. You make a change to your code, you test it again, and eventually you get it working the way you want. And like I was saying, programs should be tested with many sets of data. Now, our short little programs, right, we're converting Celsius to Fahrenheit. It's good enough for me. If you enter 0 Celsius to find out it says 32 Fahrenheit, that's the freezing point of water, and 100 Celsius to make sure it gets 212, you've tested it with 2 pieces of data. Good enough. Not many states of data. I'm going to test it with every degree, between 1 and 1,000. That's a bit exhaustive. You wouldn't want to do that. You want to test with the appropriate amount of data for the complexity of your program. And our programs are not that complex yet. So putting the program into production, the process depends on the program's purpose. Could take several months, right? You can be sure that, when World of Warcraft was put on the internet first, that it took a lot of planning. They had to put all the servers out there, all the databases out there, put all the code that was going to be out there, come up with a system for how, updates were going to be, rolled out. Putting the program into production could be a big thing. For our programs here, they're itty-bitty. You could probably just email the script to somebody, right, and tell them, hey, install Python, and then you can run this. Or you might even tell them, okay, copy and paste this program into a page on the internet and it'll be able to work, right? That's real easy, putting the program into production. And then there's maintenance. That's a common first programming job, right? Maintenance is when you take over from another set of programmers, right? They've written the software, but then they move on to something else. But then some bugs are found. Well, it could be that their time, that they're paid so much per hour that the company wants them to always be working on the new stuff. And it could be that maintaining a program takes an entirely different mindset than writing the new stuff, right? You have to be very detail oriented in order to maintain the program, which means making change requests, right? The user wants to be able to type in uppercase, you know, changing the output of the reports, finding bugs and fixing them. That's all maintenance, right? So that's making changes to the existing programs. It's not really cranking out a brand new functionality, right? Like a great big new installation pack for World of Warcraft to open up a new land or something like that, right? A big change is not usually maintenance. Maintenance are the little changes that make the program better, and usually customer driven, request driven. Something's not working. The program crashes when I press the my keyboard too many times. Okay, send that to maintenance. They'll fix it. And quite often, there's a system in place if you're working in a big team where trouble reports are filled out, and then it's up to the other team, the maintenance team, to work their way through the list to make sure that those problems are solved, right? And so they get prioritized. Well, this one causes me to not get food stamps, right? That's a big problem. This one has a misspelling on the screen. That's a small problem. You would fix the big problem rather than a small problem. So using pseudocode statements and flowchart symbols. Correct me if I'm wrong, but we talked about pseudocode. We wrote something in pseudocode, and then I think we turned it into a program. Is that correct? All right. We're going to do a little bit more pseudocode, and then we're going to do a flowchart based on that pseudocode. To do the flowchart, you're going to want to go to there is an Office app called, and I can't believe my brain just glitched on it, Office app flowchart. Visio, that's the name of it. If you want to learn the Microsoft app for flowcharting, Visio, you can crank that up and learn how to use it. I don't know how to use it. I don't use it in class because not every machine you sit at has Office installed on it, right? And the one that I'm going to show you is online, so to work on your Macs and your PCs and your Linux, it's very cross-platform. So it's called Lucidchart. And I believe you can log on and sign up for it with your school email address. Let's give that a shot. It seems like they change the rules every semester, and I haven't used it in a semester. Let's give it a shot. So I'm going to type in Lucidchart and just hit enter, and then take the top right. Lucid as in clear thinking chart. Turns out that it's just at lucidchart.com. Pretty easy to remember. I'll put a link to it, but using Google to find things is cool too. Lucidchart, hit enter. I do kind of want y'all to work along with this. You don't have to. Again, you can just upload something saying you watched the lecture. Then you're going to do sign up for free. Unless you've done this before, right? If you took the class before, you may already have a Lucidchart. Start free account. That looks better. I was getting alarmed. There used to be a separate option for student account. I'm not seeing it, but let's give it a shot. And you're going to enter your school email address. You can even try a home email address if you prefer, right? I don't care what you do. Now, I'm sure that I've already got one hooked up, but I'm going to click sign up with Google. Yeah, I already had one logged in. Sorry. Log in with Google. Oh, come on. It's being too smart for me. Is it working for y'all if you choose login? and you enter your school email address.
Yeah.
Okay, cool.
Who wants to get into our profile?
Yeah, sounds right. I mean, if you're willing to accept all that, otherwise you can use your home email address. I would use my school email address.
That's what I was trying to use.
Right, and then it's asking questions, so we're going to click allow. And it'll churn and churn.
Start the account.
Oh, wait, no, no. Right again. All right. Education, student. Home personal. Yeah, if it asks what kind of account, it doesn't really matter the questions, but I would choose home or personal. Just click that, skip that. I'm not trying to create a team. So just click the close box. I'm tired of us trying. It's trying to ask a million questions. We don't need to answer all those questions. This is the screen we need. Now, firstly, I just want us to draw a picture with it. It doesn't even have to be a great flowchart. But I'm going to open a flowchart to show you the symbols. And if you've read the chapter, you've already gotten familiar with these symbols. Different symbols mean different things. But I'm going to make a new one so that we can all play together. New document. Just start with a blank diagram, right? So you saw what I did. I went to File, New, New Document, Blank Diagram. All right, just pull something out of the flowchart box over here. Doesn't matter what it is. Pull something else. Pull something else. And by the way, we'll never use that hexagonal shape. Then try hooking them up with lines. So you move your mouse close to a shape, and you see it lights up a little circle like that, right? I move closer to the oval. It lights a red circle on the side. I click and drag, and I can hook it up to a circle on the other shape. Every shape we draw is going to be hooked up to at least one other shape, usually just one other shape. So I'm going to hook up this one to that one. Why not make a circle? This is really silly. This means absolutely nothing in flowchart language. We're just playing at this point, right?
How did you draw your line?
You move your cursor close to a shape and you see a line appear, excuse me, a circle. Watch as I go near the hexagon. You see a red circle appear there? Click that and drag and make it go somewhere. And then if you want, you can move the lines around. You see how when I move my cursor over a line, if I move it in the right place, I can stretch the lines out. You can go to a lot of trouble to move the lines around and try to make the perfect picture. I don't care if your pictures are perfect. You know, this isn't an art class. Once you've done that, you ought to be able to grab these shapes and move them around. Like I can grab my hexagon, and move it. I can grab my rectangle and move it, right? I can move my... Now, generally, we want to go top down. You don't have to go top down. All the examples in the book are going to be top down. But logically, as long as there are arrows, right, I know that going from here to here, and then the next place to go is to over here. As long as we have the arrows, then it doesn't matter if it's top down. I'm not going to yell at you if it's not top down. And sometimes you reach the bottom of a page, and you have to figure out how you're going to do that, in which case you're not going to, I mean, you could keep going down, right, and it will automatically add a page. Let me show you what I mean. I'm going to pull a square out. I'm at the bottom of the page. I'm going to move my mouse close to the red circle and drag it, and boom, it added a new page. That's great. You feel like making your document multiple pages long? That's totally cool. It's always a challenge for me to keep the flowchart, as much of it on the screen as possible, because we're not all capable of drawing these things at the exact same rate, right? And so I need to keep this, just like with the code. And so I'll try to squeeze more stuff onto my page than y'all need to. And so in order to do that, I'll be pushing things really closely together and stuff like that. You don't need to do that. You don't need to try to cram as much onto as small a page as possible. What if you need to zoom in or zoom out? Well, you can usually find a magnifying glass kind of thing. I don't think that's it. Instead, hold the control key or the command key if you're on a Mac and spin the mouse up. Spin the cursor up and we zoom way in. Spin the mouse back, we zoom way out. You get used to that pretty fast. It's like some other drawing programs. If you use the, yeah. For you, you ought to be able to, on your laptops, you ought to be able to hold the command key and then scroll your text pad up. Something like that, however you normally scroll on a text pad. A lot of the time, you don't need to zoom in. There will be occasionally times when you want to zoom in because it's making it difficult to select something. You click on something and it selects the wrong thing. And so then you can zoom in and select the right thing, right? Makes it easier to pick things when they're great big. I don't know how often I'm going to be zooming things. There are themes you can use. I want everything to look different. I want, you know, and I'm not seeing that option anymore. It used to be right here, but it's not anymore. So I'm not going to worry about the themes. But just like a drawing program, there are places where you can color. You don't have to put color in your flowcharts. There's one specific circumstance when I put color in my flowcharts, and it's great if you do. It's great if you don't. If you want to go nuts and make every single shape a different color because you're feeling artistically inclined, great. Now these descriptions are dumb. I need to edit this one that says Terminator. I want it to say Start. So I'm going to come over to the oval and I'm going to double click. And since I turned it blue, it's hard to see what happened. But see, it's highlighted the word. And I can type in something. I'm going to make this say Start. And then do something, right? That's pretty vague. Do something else. I'm just being silly. Now, look, that's almost too wide to fit in the shape. I may want to do a line break, right? I may want to size the text so that it fits in here. Quite often, I will select everything and then change the point size to make it easy for y'all to read. You don't got to do that, but you can. But what if I decided that the word do and something needed to be on separate lines? You can get that to happen. If you hit enter, it's not going to work. But if you move your cursor to where you want it and you hit control enter or command enter for the Macs, then it breaks it like that. Alrighty. I'm not sure if you hit the space bar and move the mouse, keeping the space bar down, right? I hit the space bar, keep it down, move the mouse to the trackpad. You see how it turns into a hand? Then you can just push it around. I don't do it that way very often. Usually I scroll up and down and I scroll left and right, right? But you can do that. Space bar down, keep it down, click, turns into a hand and you can grab it and move it. You guys who use Adobe drawing programs are used to that. Alrighty. We need to come up with some pseudocode. Well, first, are there any questions? Everybody was able to put some shapes and some lines and some text.
How'd you get your do something
To split lines? What I did is you double click to edit your text. You move your cursor where you want to break it. And since you're on a Mac, you're going to hit Command Return or Command Enter. like that.
Yep.
All right, good deal. Now we're going to wind up deleting everything we've done because we're going to draw a real flow chart before too long. Let me remind myself of the last homework assignment we did. Did I give you any pseudocode to do for the last flowchart homework? I'm not seeing that I did. Is that a no? We did not. But I've covered it. I just didn't give you any homework. Shame on me. All right. So we're going to write a little bit of pseudocode. And by the way, you saw how I was typing notes into idle. The way I was doing that is I started off a multi-line string by doing quote, 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 either double quotes or single quotes. That just saves me from having to do that every single time. When I'm tired of my comments, I can go in and add that, and now I'm back into program mode. Okay, so I keep talking about voting age. Let's do a voting age program. Here's what the book wants us to do. It wants us to have, or well, let me label it what this is. Pseudocode. I think I misspelled pseudocode. Is it UE? I think it's EU. Pseudocode for checking voting age. So the book always wants us to put start up at the top and stop at the bottom, and then everything's going to go in between. And I keep prefacing it with the book wants to because there may be a change that I suggest from the book way. I'll show you what I mean. And then you're supposed to start indenting. And so I'm just going to input their age. Notice that's not Python. Pseudotext is just a loosey-goosey description of it, right? It kind of follows the syntax, but it's not a programming language. If it was, I would do age equals input parentheses end parentheses. So input age, and then we're going to check the age. If age is less than 18, now we're going to go to the next line. I want to check something on the PowerPoints, excuse me. And I don't know why I have two of these things open. All right, they don't even have if statements in here, so I'm not going to sweat too much about what I'm just about to show you. But it's awfully important. So if age is less than 18, output, and I don't care if you use the word print or not, but the textbook uses output, quote, too young to vote. So output, quote, too young to vote, end quote. Now I'm going to backspace because I want to go back one level of indentation because I'm going to add an else clause to my if. Else, output, okay, you can vote. So output, quote, okay, you can vote, end quote. And I believe the book wants us to do end if there. I could be wrong on that. We'll see some examples later. Nothing wrong if you put end if there and the book didn't want you to do it. If you leave it off, I'm probably going to understand what you meant. I like seeing it. All right. And now we're going to output one more message. Output done. Okay, now this is kind of a dumb program. And I'll show you why. I'm going to come under here and stop and actually write a line of code. If the first line of our pseudocode is input age, then this is what I would do. Oh, wait, let me do my triple quotes to stop the comment. Age equals input, parentheses, end parentheses. Now that's the first line of my pseudocode. Run module. Alrighty. What am I supposed to do? The user has no idea what they're supposed to do. We know that we're supposed to type in an age. Now, it doesn't do anything yet, right? Because I don't actually have any code past that. I would like for it to tell me what to enter there. So I'm going to add a line to the pseudocode, which is going to be output, quote, please enter your age, end quote. Now, according to the textbook, you don't have to do that. According to the textbook, that's enough. And strictly speaking, it is enough, but it kind of doesn't tell us how we're going to get our input, right? How we're going to, are we reading input? Are we reading age from a file? Are we pulling in from a database? Are we asking something on the internet? To me, adding this makes it real clear that when I want you to write this program, you know what to do. You know to add a print statement. That doesn't mean that every single line down here in the code is going to have a corresponding line in the pseudocode. And I'll show you what I mean. I'm going to make a deliberate mistake because I'm going to follow this code exactly. And we're going to find out that the input step's not complete yet. Even though it's not listed in the pseudocode, it takes another step to get it to work. So above age equals input, let's add a print statement. Print, parentheses, quote, please enter your age, colon, end parentheses, end quote, end parentheses. Right, that's better. We've told them what to do. All right. Notice that we use the word print. Why? Because that's this command's form of output. If we were doing C++, don't type this, we would do this. Please enter your age. It would look completely different. If we were doing Java, it would look like this. Please enter. You get what I'm saying? Different languages do it different ways. Pseudocode just tells us that we're supposed to provide output, and then we're supposed to put our thinking caps on and figure out how to do it in our language. And we know how. We've been doing this since day one. All right, we're going to do the if statement now. If age less than 18, colon. Why colon? Because that's part of the Python syntax. If statements always have a colon after them. Not true of other languages. Some languages use curly braces, right? This is generic. This is precise. We're turning this into a precise series of commands to actually accomplish what we want in our programming language of choice. So if age less than 18, we're going to print this message. I could just copy and paste it if I was lazy. Print, parentheses, quote, too young to vote, end quote, end parentheses. Notice that I indented here. That means this code runs only as part of the if statement. If that condition is false, it's not going to do this. Really important is the fact that the if statement ends in a colon, and anytime you have a colon, the next line better be indented. You better not indent anything if there's no colon in front of it. It would be a syntax error if I put that there, right? If I run it, it's going to yell at me. That's a syntax error. It says unexpected indent. So I should fix that by going back like that. If I don't have an indentation here, that's a syntax error. Because I had a colon on the line above, that means I need a block of code underneath it. Notice I said block. One line of code is enough to be a block, but we might have 1,000 lines of code that's indented as well. In this case, one line of code is enough. It needs to be tabbed over. But we had something else we wanted to do in the pseudocode. We wanted this else clause. I'll tell you not what to do. Don't do this. There's something very wrong with that. And what's wrong with that is that this is an entire block of code we need to stop indenting. So, backspace. Your else should be at the same level as your if. And it only takes, well, like once or twice of you typing that and getting bit by it before you'll remember it forever. Again, we need our colon because we're going to put a block of code that executes only when the else is done. So print, parentheses, quote, okay, comma, go vote. end quote, end parentheses. Now, just because I have an end if here doesn't mean that I put one here, because there is no end if keyword. If I type end if here, it's not going to be orange. There is no end if keyword. If you feel like putting an end if comment there, feel free. Sometimes if I have a lot of if statements and they're nested within each other and I have while loops and stuff like that, I like extra comments to let me keep track of things. It would be totally okay to leave that out. Pretty much you can always leave comments out. At some point, I will say I want you to add comments to your code to make your code clear, and that's going to be a requirement to get full credit. But the comments, right, they're not necessary for the logic itself. All right, and then the last thing we're going to do is we're going to print done. And again, this better be unindented because it's not part of the if and it's not part of the else. So I'm going to back indent, make sure that I don't have anything indented, and I'm going to print parentheses quote done end quote end parentheses. All right, we have a program. Let's see if it works. Please enter your age. 90. And it blew up. I forgot to do something. You probably remember from the other classes and homework what I forgot to do. What should I do? Did I hear it? Pardon?
Stop.
Nope. Float. Right. I need to turn this string into a number so I can do math on it. And doing less than and greater than is part of the math. So near here, before we check it, before we do our math, after we get the input, we have to turn it into a float. So age is equal to float, parentheses age. And then you go, well, you dummy, why didn't you show that here? The reason I didn't show it there is because you don't have to do that conversion in every language. Some languages let you get an input statement and it's already a number. In those languages, you would not do a conversion step. Putting stuff in your pseudocode that is not necessary for every language isn't good, right? Because if I gave this to a Java programmer, they would either have to know, oh, I'm going to skip that conversion step, or they're going to have to really sweat what in the world we meant. So I don't have a conversion step here. I need it here. So I'm going to make a comment about input. Triple quotes. Every time you see input in pseudocode, you will need at least two things and probably three. You need a print statement to tell them what to type. You need the input statement to let them type. And you need a conversion, like a float. Right? So print statement. Tell what to type. The technical word for that is a prompt. Input. Let them type. And then float. Convert to a number. Now you can skip this step if it's not a number, right? If you ask somebody for their address, well, maybe part of it's a number, but the address is not a number, right? You're not going to add 20 to somebody's address. Zip code is supposed to be a number, but somebody's first name is not a number. I guess if you're in Star Trek and you're like 7 of 9, then 7 is a number. But anyways, usually not, right? You're not going to take somebody's name and add 17 to it. And so if you're inputting a string, you don't do that step. Everything else, for numbers, you are going to do that step. So these are the three things you have to do when you see an input statement up here in the pseudocode. Now, here, I already put the print. It was not implied. But the book will show pseudocode like this. You don't have to delete that line, but I'm showing you an example. The book will show you pseudocode like this. All it'll have is the input. If you see that pseudocode, you're still going to do a print, and then the input, and then the float, if it's supposed to be a number. Make sense? That's why I had to do this step. And I know when I'm wandering around, people are going to make this mistake. Well, it's supposed to be a float. Well, that's going to break it because it's not converting a number. Or they're going to do that. Well, what is it supposed to be converting at that point? It doesn't know what it's converting. You have to have all of the components in it. You have to have the float, you have to have the parentheses, you have to have the variable. And it shouldn't take you more than a couple of times of making that mistake to learn that. You can shorten these 3 steps all into 1 step, if and you want. Here's how you would shorten it to 1 step. I'm going to copy this stuff and put it in my notes, these 3 things. And then I'm going to come down here and paste it in my notes because I'm going to show you how to do it in 1 line. Do I want you to do it this way? No way. If you don't feel like doing it this way, it's totally cool. I'm not going to ask you on an exam how to do it like this, but maybe you like it. So here's how to do it with 1 line of code. Done in 1 line. Age equals float parentheses, input open parentheses, quote, please enter your age, colon, end quote, end parentheses, end parentheses. Now, why 2 parentheses? Because parentheses always has to match, just like if you're doing math. That one matches that one, and that one matches that one. If you like the way that looks, if that makes sense to you, feel free. If it doesn't, just jettison it, right? Pick away. You can switch between them all you want. I will occasionally do it this way. I will sometimes use the fact that you can put your printed words inside it, right? Right, so like temp is equal to input, you know, what is the temp, right? That's cool. That's easy enough to look at and remember what it's doing. It's just going to print this message, and then it's going to ask for the input, and it's going to store it in a temp. To me, this is almost too much, right? Doing the float at the same time that you do the input, it's perfectly good programming, and you'll see a lot of programmers do that. But like I said, it's almost too much. The only thing that's holding me back from wanting to do that every single time is if I like seeing the print statement and the input statement separated. And I do. I really do, because when we draw a flowchart, they're separated. And I don't like our flowchart looking too different from the pseudocode. But this works. We can do that. You'll see me type that. I probably won't type it if I'm going to draw a flowchart from my code. But usually you do the opposite. Usually you don't make a flowchart from the code unless you need to just document some existing code to understand what it's doing, right? The flowchart's supposed to be the, the diagram for how you're going to code it, right? I want to write some programs, so I'm going to make a flowchart, and then I'm going to use that logic to make a program, right? Not vice versa. Doing it vice versa is like building a house and then writing the blueprints. You can do that, maybe, but you should come up with a blueprint and then do the house. All right, I'm going to stop my comment here again, so I'm going to put in more triple quotes. Make sure the next thing I type in is black to show that it's not a syntax error. Let's run the code and make sure it works. I did add the conversion, did I not? Yes, I did. Let me get rid of that because that would crash it. All right, testing it out. Please enter your age. I'm 90. Okay, go vote. Now, I said that you're supposed to test it to see if you can break it. Make sure it works for all reasonable cases. What's a reasonable case? Well, what's an edge case? What is the boundary? 18 is the boundary. Let's make sure that it works for 18. Please enter your age, 18. Okay, go vote. How's about 17? Right? 17. Too young to vote. Okay, that seems to be working. I've tested both sides of the boundary. Will it accept decimal points? What if I'm 17.5 years old? Yep, still too young to vote. All right, I'm going to pause this, make sure everybody's doing okay. All right, so what we're going to do next is we're going to turn that pseudocode into a flowchart. And we're going to see that each line of pseudocode has a symbol in the flowchart. The start and the stop are ovals. The input statements, I'm going to use a silly name and call them tilted rectangles. I forget whether the book calls them quadrilaterals or parallelograms, but technically a rectangle is also a quadrilateral and a parallelogram. So I like calling them tilted rectangles and regular rectangles. Math is done in regular rectangles. Like if we did A equals B plus C, that's a regular rectangle. Printing and output is done in tilted rectangles. And you're not going to remember this until we actually draw it. Decisions, if statements, and while loops are done in diamonds. Can I tab away from this text yet to go back to the drawing program? Go away. I type words for somebody watching.
Okay.
All right. Okay. So I'm going to go to my flowcharting program, and to try to get the pseudocode and the flowchart on the same screen, I got a couple of different choices. One is I could just slam this window on the side, and then come back over here, and where's my flowcharting program? Slam this on the other side. Doesn't work for you Mac users, but you know how to move your windows around. That's one thing I can try to do. However, that kind of limits my drawing space. What I'm going to do is I'm going to take this pseudocode and stick it in a box so that I can refer to it. And I like seeing that. I like seeing your code or your pseudocode on the flowchart itself. So I'm going to scroll up here to where it says start. I'm going to copy all that from start to stop. I'm going to delete all of that. So I'm just going to highlight all of that stuff and hit the backspace, make it go away. We don't need that stuff anymore. Or you can do file new, either way. Now let's see what this box is. A block. Block looks good. I'm going to grab the block, move it over here, double click and paste and put my code there. Now that's not perfect, right? It's not tabbed correctly and stuff like that. But it's good enough for me to go with. Maybe I can make it better. Maybe I can make it so-called left justified, right? Not right. Yes. So I'm going to double click again, highlight all of that. And you see this thing? This thing means center your text, I believe. I don't want it centered. I want the text right justified. Left justified. All right, why did I put that there? Just so that that code is available to me when I start drawing. All right, now I'm going to start drawing. I'm going to drag an oval out. The oval is called a terminator, or the terminal. But not only does it end it, it begins it. So I'm going to grab the oval, drag it out, and I'm going to rename it so that it says start. Just like the pseudocode. Start. Looks like I deleted my print statement here. It's okay. Didn't mean to, but it's okay. I'm going to squeeze that down, but only because I need to shove as much code on the screen as possible. All right. Now I need an input statement. Input statements are done in what this thing calls the data blocks, which is the tilted rectangle. Drag a tilted rectangle out. I'm going to show you another way of doing this. I'm going to undo that. Notice if I move my cursor to the place where I draw a line, and then I draw a line, it offers me a choice. Right? That can be a fast way of doing it. Usually I don't remember that, and so I just grab something and drag it out and draw the line later. All right. This is an input statement. Input age. Now that's taking way too much space on my screen, so I'm going to shrink it down. Again, you don't have to. And I'm going to draw a line from start to input. Every box will have at least one line going to it. Usually only one line going to it. and at least one line leaving it. Usually only one line leaving it. Pretty much, you're going to see every box either has one or two lines coming from it or leaving it, and usually just one, except for the start and the stop. There's no line going into start, and when you hit stop, there's only going to be one line going into it with no lines leaving. If you have let me drag something out, right? Don't do this because I'm going to delete it, right? If you have that, and then you have something else like this, and you have a line here to here, but you forgot to add that line, you're not going to get full credit for your flowchart, right? There can't be any dead ends. There has to be a way from the start all the way to the stop with no breaks. Everything has to be hooked up with a line. Now, that doesn't mean that you just hook them up randomly. Okay, well, professor told me I need a line. I'm going to put a line like that. And I'm going to put a line like, no. The lines all have to go the right way. I usually make them top down. Okay. This is a decision block because it's an if statement. All right. There wouldn't be anything wrong for my purposes about showing the conversion step here, right? I could say convert age to a number. It's not shown on the pseudocode, so I'm going to leave it out. I'm not going to count off on you if you make your flowchart more complicated than the bare minimum, right? If you go to that extra word, fine with me. But I do want the bare minimum, and the bare minimum is what's in the pseudocode. So if age less than 18, and I have a little quirk, I like to put the word if above the word age. So I'm going to move my cursor to the word age and hit Control Enter or Command Enter for the Mac users, like that. I just like that. The book won't even show you using the word if. This is textbook perfect, leaving that out. I don't like the textbook perfect way of doing it. The reason why is the same shape is used not only for if statements, but for while statements and for for statements. So I like labeling it. This is a place where the professor's rules are a little bit different than the book's rules. I'm not going to count you off if you follow the book's rules. But every time we're in class, I am going to add the word if it's an if statement. Because I don't want to have to magically think to myself, well, is that an if, for, or while? Right? I just like being able to see instantly. All right, I'm going to see if I can resize this a little bit to save some space on my screen. Again, you don't have to. Maybe I can maximize this. Yeah, that's looking better. Okay, now I have an if statement. If statements have two lines leading from them. One is a true line and one is a false line. One is what it does if the if is true, and one is what it does if it's not true. Right? So here's what happens if it's true. If it's true, we do output too young to vote. Now, I like making my if statements go off to the right for the true. You don't got to do that. You can make it go off to the left. You can make it go off diagonally. One professor insisted that doing it to the right was old-fashioned, and he was always going to make students go to the left. But when we have an if, what's the next thing we do? We tab. What does tabbing do? It pushes it to the right. So I like drawing the line to the right. Okay. And what's the next thing that happens? Notice it says yes rather than true. Some flowcharting programs would say true. But if the age is less than 18, we need it to do an output. So I'm going to drag an output box. Input and output are both done in the same shapes. So I need to output, and like I said, I like putting line breaks in mine, so I'm going to hit Control Enter or Command Enter. Quote, too young to vote. And that's still looking kind of cheap. Okay, there, it fixed itself. But I need room for my else. I didn't even leave myself room for the else. I put this big box in the way because I'd like for the else to jut off the other way. I guess I'm just going to grab this box and move it to the other side so that I have room for my else. All right, here's my else. I wish it said else. It doesn't say else. And notice it's going nuts. If the line starts going nuts, you can just highlight the line, delete it, and redraw it. You can spend a lot of times making these things. Well, that's cool. Do I want that? Nah. Am I going to count off if you turn something in like that? Nah. Once more with feeling. Come on. Draw yourself right. There. I like that better. All right. And so if it's a no, it's supposed to be output, okay, you can vote. I don't care if you use the word print rather than output. Output, and I'm going to put this on its own line. You don't gotta. Control Enter. Okay, you can vote. And that looks kind of lame, so I'm going to go and I'm going to put another line break. So I'm going to move the cursor before vote. You don't gotta. And I'm going to take the time to line these things up like that and reshape them a little. Do I care if you do that? No. Like if I ask you to draw a flowchart during an exam, then absolutely do not take time making it pretty, right? If I did that, it would not be a hard flowchart. Right, I'm not going to require you to write a book, so to speak, or paint the Mona Lisa just to pass an exam. Alrighty, now, these things have to eventually join back up together. So I'm going to put just a little circle down there to be a connector. I'm going to find the circle, it even calls it a connector, and drag it down here. It doesn't have to have that A in it, so I'm going to double click and remove that A. And I could make the connector nice and small if I wanted to. And then these things are supposed to hook back up together. The flow of logic always has to hook back up together somehow. Once things branch off, they eventually need to hook back up. Hope that's true. For now. For now, that's going to be our rule. Right, we can always learn exceptions to the rules later. Then what's the next thing after? And by the way, check this out. We have the word else here, so everybody always wants a box that says else. There is no else box. It's implied according to our logic, right? If age, do that. If that's not true, do that. If you really want to see the word else, change that word no to an else. Just do that if you want. This is not textbook right. We're allowed to do things that aren't in the textbook. You can put the word else there if you want to try to make it match the code. Now, if you hand this to a computer scientist and he looks at it and goes, else, he is going to know why you did that, and he's going to think that it's kind of childish. Also, he's going to kind of think that the word if is childish. But we can do what we want, dang it. So, you like the word else there? Great. If you want to leave it no, leave it like that. If I'm in a hurry, I'm not going to change it to an else. The textbook will never show that. I need to make a little document that says, you know, professors' acceptable or recommended variations from strict flow charting. All right, what's the last thing after our indif? And this is effectively our indif. I'm not going to put a comment or write indif in it. It's implied, right? But we have an output statement, so I need an output statement underneath it. I'm going to come over here, grab another data block. It's a tilted rectangle. You have to get the shapes right. If you start putting math in tilted blocks and then you put output input statements in regular rectangles, then you get counted off a lot of points and I ask you to redo it. Okay, so I need an output. I probably shrank it too small. You shouldn't shrink it until you're done drawing it. Output.
Can you just copy the input?
Yep. Could have done that. Save time. And then I need to draw a line from one to the other. It's giving me grief. It's not giving me the red line. There we go, finally. And quite often people want to stop there, but just like you have the word start, you have to have the word stop. So one more box, but it's not a box, it's another terminator. Stop. All right, that's our flow chart. That is a well-drawn flow chart, other than the professor's personal eccentricity of putting the if statement inside the, adding the word if to it. Changes you can make. I don't care if you say input age or age equals input parentheses in parentheses. It's not strictly correct, but it looks like Python. You feel like doing that, that's okay, right? I could come up here and do age equals input parentheses. This is better. This is more correct. You didn't put a colon here because we're not doing Python coding in here. We're doing pseudocode. One more comment I want to make about pseudocode and indentation is notice how this is indented after start. We don't do that in our code, right? When we're writing our code, just because we had start and then a bunch of stuff that was indented and then we had a stop, if we had indented this stuff, it would be a syntax error. So I am considering the idea, and I mentioned it to the other class, of not indenting everything after start, right? Making it look like this. But to be textbook perfect, I should leave it indented. So if you start getting confused about when you indent and when you don't, I'd recommend that you modify your pseudocode practices rather than trying to make your code indented to match the pseudocode. But I need to go ahead and do it textbook perfectly in my examples, so I'm going to go ahead and leave it like that. That makes sense, though? Just because there's a start and an indentation here, there is no start keyword here, so there's no indentation involved after that. All right, we're so proud of our flowchart that you want to upload it. Not upload it. You want to download it.
I got a question.
Uh-huh.
The circle down.
Yeah.
Mine has an A in it, so.
You can get rid of the A, kind of zoom in, or maybe you don't even have to zoom in. Double click it and then backspace over the A.
Okay, I just thought maybe.
And you can leave it A, because I'm not going to count it wrong. I understand, right, that it put it there. You don't have to take the time to delete it, but it makes it look prettier if you do.
So why is it there?
It added it.
The zero. I mean the.
It added it, and then if I drag out something else, maybe I'm going to put,
No. Why is it? Why is the circle there, and the two arrows meeting before it goes down?
We have to have some place where they join.
Oh.
You will see some people do it like this. You could make these boxes go directly to this like this. But I believe the textbook's going to show them meeting before it drops down. And so the easiest way to make them meet is to put a connector.
That's a connector. Okay. Couldn't I just write in that circle connect?
Put whatever you want in there, as long as I understand it, as long as you understand it. Okay, we need to save our file, and I hope that as a student account you aren't restricted in saving your file, so do save and call it what you want, like Lecture D, voting, something like that. So you saw what I did. I went to the File menu. Let me get out of Zoom mode. File, save. Now I want to download it so that I can submit it to the Dropbox. Actually, I'm just going to put it in the notes, but you're going to submit it to the Dropbox. If you get stuck and you can't figure out how to download it, you could screenshot it, but that's kind of lame. So instead, when I say lame, that doesn't mean that I don't want you to do it if that's the only way to get it done, but this is better. File, download as, and you can pick any of these formats, but PDF is a pretty dang good one. Right, because you could email that to your kids and they'd still be able to open it. So download as PDF. Hopefully it gives us a chance to enter a name and pick where to save it. Now, I don't seem to be getting that chance over here.
I got a name document here, and then hit save.
Okay, yeah, that's right. We gave it a name when we saved it. For some reason, it is not letting me type in.
What'd you call it?
Well, what I'm saying is that it's cutting off. It's clipping part of the dialogue, so I can't see everything. I'm going to try it again. Alrighty. Well, if I can drag it over and reach the OK button, I hope it. Y'all see the OK button, right? It's not doing the same thing on yours that it's doing for me. Is that true? It's nobody has seen the OK button, right? You can't. Alrighty. Well, I'm going to hit it, and it downloaded it over here. It didn't give us a chance to pick where we were downloading it to, but that's okay. We know how to use our browsers and to find the file so we can upload it. So
What'd you save it as?
I let it pick the name because I did a file save and I called it lecture devoting and I chose PDF as the file type. That's what you want to upload. Upload your PY file too if you want. Let me make the Dropbox for that and then I'll tell you what the homework's going to be. Alright, there's a Dropbox. Please give me your PDF just so you can refer to it later. And I know you did it. Now, if you didn't draw a PDF because you just wanted to watch the whole lecture, do the usual and upload a note saying you were here. It's better, especially for the drawing stuff, if you try to work along. Alright, I need to come up with some homework for y'all. It's going to be very similar to the Dropbox that we just did. But I don't want you to copy and paste that drawing. I said Dropbox. It's going to be very similar to the flowchart you just made, but like I said, I don't want you to just copy and paste. I want you to create a brand new, a fresh flowchart that looks like this. Start, input, X, input, Y. Put those in two separate blocks. Don't put those in the same block, right? This goes in one diamond. This goes in another diamond. And then our if statement. If X plus Y equals 0, then print or output result is 0. This is dumb, but it's just for flowcharting. Else, output result is non-zero. Then I'm going to do the end if, and I'm going to output done. You see how similar those things are to the other one, but I want you to draw it. It's okay to, you know, reference it, you know, flip between the two.
So you just want to make a flowchart?
Right. Make a flowchart for that.
Okay.
Exactly. Right. I'll also have you do, you know, pseudocode of a program later, but not now. This is just homework. And you could probably draw this in, you know, in 10 minutes before you left the room if you didn't have anywhere else to go. But you know how to do it. You can do it at home as well. So homework, draw a flowchart that looks like this, or that describes this logic. Alrighty. I'm going to take a roll. Don't need the recording going for that. Any questions?